We've used tr to convert the set of control characters to new lines. The input is taken from our mount point, and then the resulting stream is piped into grep, where we then proceed to do our string search. Cyberbullying is definitely not cool. All right, so here is the entirety of the document, and instead of outputting it to that file, we could actually just pipe it directly into Antiword, and I will pipe that into less for some pagination, or for some pagination. And there we go.
Fresh forensics, baby.
What's up, everyone? We are back again with another video on forensics, which makes sense because I did name my channel Fresh Forensics. Alright, so in today's video, we're going to continue down the path of digital forensics using Linux, specifically Kali Linux, as our platform. And we are going to do a physical string search on an NTFS image, or in other words, a Windows image or a Windows file system, which is NTFS. So we have a directory that was previously created called forensics. I see the inside of that directory and do an ls. Here are various files, all of which I have acquired from linuxleo.com. Links are in the description. An absolutely incredible source for Linux and digital forensics. So the files that I am using, I have acquired from that site underneath supplemental files. All right, so we're going to be doing some more stuff with this NTFS image. I've already extracted it. See the inside of the directory, do an ls. We have 4 different files, all of which are images of an NTFS file system, specifically in EWF format. We have covered this already. So basically what we are doing is we're searching for a string. We're searching for a string within the image. The image contains all sorts of files. Could be PDF files, TXT documents, images, all sorts of things, and we just want to search for a very specific string and then attempt to locate exactly where in that image we are finding this specific string. This sounds very simple, but if you don't know how to do this, it's not as simple as it seems, especially when we're dealing with very large images. Now, since these are EWF images, I am going to use the ewf-mount command to mount the image. If you do not have these utilities installed, you can run apt-info on ewf-tools. It'll give you some more information on this set of tools. If you don't have them installed, simply run sudo apt install ewf-tools. And once you have those installed, you can type ewf, hit tab, and you should have these 8 different command line utilities available to you. All right, so from this point, some of the commands that we are going to run are going to require sudo privileges. So it'll be easier if I just switch to the root user. And I'm going to create a mount point to mount this image to, and I'm going to do it from right within the current directory that I'm in. So we're going to create the mount point from within the current directory. I'm going to do that using the make directory command, and I'm going to call this mount point evidence. Now we're going to use ewf-mount. We're going to mount the first of these 4 images ending in 01, and we're going to mount it to that newly created mount point. And you'll know if this has completed successfully because you will get this output. It will say ewf-mount, and it will be followed by a series of digits. So now if I run the ls command on evidence, you see that ewf1 is now showing up. Okay, so now we're going to use the grep command. If I do a what is on grep, we get back that it is used to print lines that match patterns. So we are actually going to grep through this entire mounted image, and we're going to grep for any text strings that match the term cyberbullying. So if I pull up the help menu for grep by typing --help, I'm going to show you real quick the options of the flags that we're going to be using with this. We're going to be doing A, B, and I. -A will allow us to search for text. It will treat it as a binary file. By specifying -B, we're going to print the byte offset. That'll help us better locate specifically in the image the thing that we are searching for. And finally, the I, lowercase I, is used to ignore case distinctions. Basically what that means is search for that string regardless of its uppercase or lowercase. Alright, so we're going to run grep with -ABI. The text string that we're looking for is cyberbullying, and we are going to run that on that mounted image. We get back a decent amount of information from running that command. You can see that the string that we're searching for, it does show up. It shows up in red, and you can see in various instances, some of it is lowercase, and then there's a few hits that in which it begins with a capital C. So that's why we did the -I. And then we're getting the entire context that this falls within. Now, one thing that you're probably noticing is that when we ran this grep command, we are also getting back several non-ASCII characters, and that kind of interferes with our readability of this text. So you can see up here at the top, we got some gibberish, and also our offsets have been obscured. All right, so this is where we're going to make use of another wonderful command line utility, and that is tr. So if I do a what is on tr, we get back that this is used to translate or delete characters. We're going to use this to remove as much of that unreadable content as we can that we don't want to see. So I'm going to run tr, and this will be in the description, provided that some of these characters are allowed to be in the description, because some special characters don't fall in the description well. I'm going to run tr with 2 single quotation marks, and inside of those single quotation marks, I'm doing square brackets. Inside of the square brackets, we're doing a colon and cntrl followed by another colon, and then space over, and once again inside of single quotation marks, we're going to do a new line character, which is represented by a backslash and an N. This is typically what is represented by going to the next line when you are at the end of your previous line inside of a text document, for example. And I'm going to use the redirector operator, and we're going to specify that mount point, and we are going to pipe everything from that grep that we ran using -ABI, searching for the term cyberbullying. Now what we get back is much better than what we had prior to this. So we have gotten rid of all of those unreadable characters on the screen, and we have all of our offsets showing up on the left hand side. And when I say offset, I'm referring to the very, very specific point inside of this image where we find each one of these strings that we are searching for. This is exactly where you would find it inside of that image, and we have every single reference of this string with the offset showing up on the left hand side. So what we have done by running this command, other than the obvious, is we've used tr to convert the set of control characters to new lines. The input is taken from our mount point, and then the resulting stream is piped into grep, where we then proceed to do our string search. All right, so the next step is going to be for us to actually calculate what sector the keyword is in, the offset within the volume, and finally which data block and metadata entry is associated with the keyword hit. So we first have to determine the sector offset. We do this by dividing the byte offset by the sector size. So this is the byte offset. The sector size is 512. That's the size of each sector. They're all 512. So we're going to go ahead and copy that sector offset. If I do a what is on BC, we get nothing back. I don't think it's installed. If I do which BC, it is not installed. Okay, so if I do an apt search for BC, BC is the GNU BC Arbitrary Precision Calculator. It is not installed by default on this Kali Linux image, so let's go ahead and install it by running apt install BC. And now we are going to use the echo command. Inside of double quotation marks, I'm going to paste in that sector offset, and then we're going to divide it by 512, which is the byte offset size, and we're going to pipe that into our calculator BC. And if you are unsure about the sector size, or if you're trying to apply this to other images and you don't know for sure how to determine the sector size, if we run mmls on this image that we're looking at, you see that what comes back is that it is in sector sizes of 512. And if I run the fs-stat command with -o, I'm going to specify the starting byte offset for this NTFS file system. And then I have to provide it with the name of that image. We get back some information pertaining to this file system, and we see that once again we have a sector size of 512, and we have a cluster size of 4096. The keyword that we are searching for is sitting in an NTFS partition, of which starts at an offset of 2048. So we're going to do a little bit more math to determine where exactly in which block that keyword resides. So I'm going to run the echo command again. This time I'm going to add a little bit more math here. So we're going to do 2048, which is that starting byte offset. We're going to times that by the block size, which is 512, and we're going to divide that by the cluster size, which is 4096. And I need to put in one more bracket, I believe. One more set of brackets. And hit enter. So the resulting number that we get from this somewhat complex math, at least complex for me, is 103,893, or 103,893. So what we have done is we have taken the offset to the keyword that was from that grep command. We then subtracted the offset to the start of the partition, and then we divided that result by the system block size, which is also called the cluster size, which is 496. And the result is a value for our file system block. So now we're going to use a command called blkstat. This is used to display the details of a file system data unit. Which one are we going to display the details of? This one right here that we just found. Okay, so I'm going to run blkstat. As with all of these commands from the Sleuth Kit, we're always doing -o, and we're specifying that starting offset for that partition that we're looking into, which is 2048 in this example, and then the name of the image. And then we're going to specify the number for that particular system block. And hit enter. All right, so what this tells us is that this particular cluster block is not allocated. Next, I'm going to do a what is on ifind. This is used to find the metadata structure that has allocated a given disk, unit, or file name. So we're going to run ifind, once again specifying that offset, the name of the image, and this time, right after that offset, we're going to do -d, and we're going to specify that particular system block by that number, and hit enter. This provides us with the MFT entry for that particular block, that data block. So now that we have identified the MFT entry, or the metadata structure for that data block of interest to us, we can then use the icat command. If I do a what is an icat, this will output the contents of a file based on its inode number. So now we're going to actually get to the contents. So we're going to run icat, once again, -o, specifying that offset 2048, the name of the image. We're going to specify the MFT entry number, which is 248. We're getting that from right here. And we're going to pipe that into the file command, and I'm just adding a dash at the end. And what we get back is that we are dealing with some sort of a document. It looks like a Microsoft Word document. Now notice that when we ran that icat command, that we passed it only that MFT record number, not the entire attribute, since we are only looking for the default attribute, which is data. Now if I rerun that command, and instead of piping it into file, I pipe it into less, so we're going to basically attempt to view this in ASCII form, we get back a bunch of gibberish. We get non-ASCII characters, so this is not going to work. So instead, what we're going to do is we are going to use icat once again, and we are going to redirect it into a new file. And since the text string that we were looking for was called cyberbullying, I'm going to call this cyberbullying.ntfs because it's coming from an NTFS file system. Since we know this is a Microsoft Word compatible file, we could attempt to view this with something like LibreOffice, which I'm not sure if that's installed by default on Kali Linux or not. I don't think that it is, so let's go ahead and do a search for LibreOffice. Okay, so it is not installed by default. We can install the entire meta package by running apt install LibreOffice. This is one way that we can view this document or file, so we'll let that install. Okay, so the LibreOffice meta package has finished installing. That did take a few minutes to install. Now if I open up the applications menu and type in LibreOffice, you can see that we now have all of those various packages installed. So we're going to go ahead and open up the first one specified by LibreOffice. And I have to locate exactly where that file is. It's inside of Forensics, inside of NTFS practice, and here it is right here, cyberbullying.ntfs. So here's our document, and we have managed to open this up inside of LibreOffice on Linux, Kali Linux specifically, even though this is a Microsoft Word document. And cyberbullying is definitely not cool. Go ahead and check out www.stopcyberbullying.org. All right, so here is the entirety of the document. It's 2 pages long. Very cool. But this doesn't really work for us very well because the general theme of everything we're doing is to do everything from the command line. All right, so another way that we could open up this document strictly from the command line and adhere to the general theme of these videos and the way that we do things is going to be to install a command line utility called Antiword. So if I do apt search on Antiword, this is used to convert MS Word files to text files, which is what we want to do since we're on Linux. This is also not installed by default. So I'm going to run apt install Antiword. Now that we have that installed, a couple different ways we can do this. We did save this to a file, so we can simply run Antiword and specify that file. And what we have now is a Microsoft Word document that has been converted and output to the screen in text for Linux users. Another way we could have done this if we did not want to actually save anything to a file would have been to rerun one of those previous commands. We could rerun that icat command, and instead of outputting it to that file, we could actually just pipe it directly into Antiword. And I will pipe that into less for some pagination or for some pagination. And there we go. And we can hit the space bar and we can scroll through that. Pretty cool, huh? So this is really getting deep into the weeds of forensics with Linux as the platform. All right, so now I'm going to do a queue to quit from that, and we're gonna wrap this video up. But I'm also going to give you a quick teaser for what is going to become the next video. In the next video, we're going to be looking at a command line utility that is most likely installed by default on your Kali Linux system, but you probably have never heard of and definitely have never used, and that is called bulk extractor. If I come up here to the applications menu, come down to forensics, it is this utility right here, bulk extractor. This is used to scan a disk image for regular expressions and other content. I've just recently become aware of this tool, and it is absolutely incredible. Never knew the power that this tool had, and the whole time it was on my Kali Linux system. Absolutely incredible tool. We're going to do a whole video just on this tool, but the segue into that is going to be that as wonderful of a utility as Grep is, and Grep is incredible, Grep is very powerful, there are certain situations where it will fail us in what we are trying to do. And that is how we are going to segue into bulk extractor. So we're going to grep once again with -abi, but we're going to grep for a different string. This string is going to be uranium -235. Yeah, I know it sounds like something from the periodic table of elements, but that is actually not what this is. And we are going to grep for this string on that mounted file system that we still have mounted over at evidence/ewf1. Now you see that it returns nothing. So we have not been able to find any string matching this string of interest. I wonder if bulk extractor can find it. If you are enjoying this content on forensics, and judging by the incredibly large amount of views and new subscribers that I am getting right now, I'm gathering that people are enjoying the content. Well, then let me quickly encourage you to go back over to my channel and hit that subscribe button. Now, this is incredible. I'm so thankful to everybody right now. So incredibly thankful, because currently I'm getting 100+ new subscribers every single day, and that has just been absolutely amazing. It's so rewarding to see all the effort that I put into this channel finally paying off. So as of yesterday, I hit 4,000 subscribers, and it just keeps climbing. I'm getting over 100 subs a day. So thank you to everybody who has subscribed. If you are not subscribed, go ahead and hit that subscribe button right now. And as always, keep learning
and stay fresh.